Cool. I think we have almost everybody here. No, everybody here. Oh, that's awesome. I think. How's everybody doing? How's like aftermath of first study group? Okay, good. I see more subtle nods than like handshakes, so I'm glad. Good to see, good to see. All right, today's study group will be a little bit different. We're actually gonna move a little bit away from coding to talk about Git and Bash. I will say this is probably for some students like the hardest thing to understand, Git and Bash. It's a necessary evil, we'll see why. And through this topic, I will walk through a couple of scenarios in which you will need to use Git and Bash. There will be another time that you'll need to be using Git, and that's during the projects, but don't worry about that for now. I'll walk through the full setting up a project on GitHub process when we get to the project. So the two main processes I'm going to be talking through are working on your labs locally. So I don't know how many of you have made it through. I think they do talk about it in a bit of topic 1, but working on your labs on your local machine rather than on the Lumidisk. So I'll talk about what that means and how that works. After that, I'll actually be talking about our study group repo. And let me actually bring that up. Please log me out. Has like the colors of canvas changed for you all? Like I was having different colors and now it's in dark mode, which I kind of like, but these colors are different from what I had yesterday. But cool. We're going to be talking about this study group repo. So at the end of last study group, I had asked you guys to all fork and clone this study group repo. And no worries if you haven't. I just want to talk through what we're going to be using this for and how we're going to use it. All right, before I get started, any questions regarding maybe anything that we worked on yesterday or general questions?
Nope.
Nice, awesome. All right, let's get started. The first thing we're going to talk about is working on labs locally. And so when do you want to do this? Previously, a lot of students worked on labs locally because I guess this is not as common now, but I have some students that like would have plane rides or train rides and just wanted to work on labs without needing internet. And so what you would do is then just like clone a bunch of your labs down on your local machine so you actually don't have to connect to the internet or work up Lumidesk to work on your labs. So the process of doing that, I think there are instructions somewhere in topic 1, but I'm going to go through an example here anyways. So to work on something locally, you would have to clone it from GitHub. And what you would do is like on a lab, you'll see this AutoCat button, and that opens up the GitHub page of the lab. And so Illumidesk actually pulls from GitHub to create the labs that you work on. And so each of you will have your own copy of the lab. So cool. Once we're at this page, one thing you want to do is fork the lab. And what forking the lab is, it creates your own version of the lab. So a bit of GitHub, I guess, terminology. This is the name of the repo, and this Learn Code curriculum is the owner of the repo. So right now, if I were to make changes on this version, it won't let me make changes because I'm not authorized to make changes through curriculum. So what you would do is you would fork the lab. And yours will look a little different because I have multiple GitHub accounts. But I would fork it to my own personal GitHub. And it does take a while because it's copying everything over. And you'll see now that this repo belongs to me. And it will also say that it's forked from this. So this is a version that I actually have authorization to change. So what I would do if I want to work on this locally is I click the download code button, make sure it's HTTPS. SSH also might work, but you do need to like get your credentials set up, and that's not super important. You very unlikely will need to use this for now. And GitHub CLI is this new command line interface that literally came out in like the past couple months. So I honestly don't really know how it works either. So make sure it's HTTPS, copy this link, open up your terminal, and this is a new terminal window. Let me make this bigger. decide where you want to save these labs. So let's see, I actually have a data science folder, which I think I mentioned yesterday. Change directory, as I mentioned, is to change directory to move into specific folders. ls lists all the folders you have, and I actually have a folder for labs. So let's move into that folder. cd into labs, list the files that I have in here. So you see here I have a bunch of labs, and I want to clone this lab, this Python operators and functions lab into here. So what I do is do git clone and paste that link that I had copied. It'll do a bunch of that copying over, and now this lab exists locally. So if I list all my files again, previously here, that lab wasn't there, but now you can see in this group of labs, it's right over here. And so automatically when you git clone something, it doesn't bring you into the file. That is one step that people often forget. So just remember that you have to cd into that file again. And one helpful thing to remember is tab autocomplete. So just know that tab will autocomplete your folder name until there are multiple folder names with that same whatever it is. So here, all of them start with DSC. And let's see, this is the only one that starts with P. So if I start typing P, I press tab, autocompletes. So I do that, and you'll see that I'm actually in that folder already. And all I have to do now is to launch the lab by typing Jupyter Notebook, and that launches the lab locally in my browser. So these are all local URLs. So the labs are any notebook file. So IPYNB stands for IPython notebook, and those are the files that you'll be working on with. So if you click on your IPYNB file, you can start working on a lab, and this is all saved on your computer. So you can work on this if you have no Wi-Fi.
Question.
Mm-hmm.
Is this recorded?
This is recorded. Did I press the record button?
No, I mean, is it? Okay.
Oh.
Is it posted?
Is this video going to be posted?
Yes, please.
Yes, this video is going to be posted.
Thank you.
Yeah, great question.
Something?
Sorry, what was that?
We're gonna post it.
Yeah, I'm gonna post the link to this video after it uploads to YouTube.
All right, appreciate it.
You're welcome. All right, so saving my work locally works with this save button. So let's say here, let's work on some stuff. Actually, let's just make some, let's pretend I'm working on this, and some really quick Jupyter Notebook shortcuts. If you want to add blank cells, you can press this plus button, or you can press, make sure that this is blue, not green. Making sure this is blue, if you press A, it adds a cell above, B adds a cell below, and X deletes the cell. They're just handy shortcuts to know. Anyways, let's just define a pretend function just so we can see how work saves. So define function, and for now, let's just return nothing. Does return pass not work? Never mind. Yeah, return pass is not a thing. All right, return none. All right, so let's say I work through this lab. This is my change that we'll look out for. Let's save this, close this out. And in your terminal, you quit your notebook by doing Control-C, typed in Y to shut it down, and your work is saved locally. Now, once your work is saved locally, it's a good idea to also push your changes up to GitHub. So what does that mean? So when you clone something down, your local machine recognizes it as a GitHub repository that is connected to some GitHub link online. One way to look at that is if you type Git Remote -V, you can see what links it's associated with. So I typed in Git Remote -V, let me make it a little bigger. After typing Git Remote -V, it says that the fetch URL is this GitHub URL, which makes sense. This is my account. This is the name of the repo. And what did I just do? And the push, same URL. And we'll get more into this a little later. Did I just paste this link? All right. Unfortunately, you can't like highlight and mass delete things in terminal. All right. Because it is a Git repository, I can type in Git Status to see just what's going on. Git Status is actually a really good thing to just type whenever you're working with any sort of Git repository, just to see what's happening. So typing in Git Status, a bunch of gibberish comes up. We're up to date with origin master. We'll talk about what this means later. And you can see that there are changes not staged for commit, and that I had modified the index.ipynb file. And that's right, I had modified the notebook earlier. I made that one random function, and so it recognizes that there's that change there. And so what you want to do is you want to add, commit, and push that change onto GitHub. Because right now, that equivalent repository is here, right? That link that came up when I showed Git Remote -v. -v stands for view. Let me just refresh it. When I do that, that's this page over here. And ideally, I want to get my changes on this page, just so you know it will exist on the internet. It's just useful to have. If you change computers, that's very useful to have. So what we'll do is 3 steps that always come together: add, commit, and push. So git add, and you can either git add a specific file. So here I only changed index.ipynb, so technically I could do index.ipynb, or a shortcut, because I know that this is the only thing I changed. One thing, if you happen to change like multiple files, I like to do git add and then space period. And that's just a shortcut for saying all. So that stages your commits. Staging is sort of like an intermediate area, kind of like purgatory or something like that. So after you stage your changes, you then have to commit and push them. So next step after you add is commit. So we'll do a git commit. Git commit always has to come with -m, because every commit has to come with a message, and that message has to be put in quotes. So let's see. Make sure your commit messages are meaningful. Sometimes I get really frustrated and then I put gibberish in my commit messages. I've been called out by recruiters for that, so don't do that. So git commit -m, and here I said I added a function. So that will be my commit message. And I'll show you where that comes up later. All right, so here you can see that a file has been changed, some insertions, some deletions, and we rewrote this index file. Cool. Last step we need to do is just git push. So there's sort of 3 stages. You stage your commit, say what the commit is, and then push your changes up to GitHub. So when I do git push, sometimes it takes a little while depending on your file size, but you can see that that's done. Resolving your deltas. Deltas means change. And then from master to master. We'll talk about what master means later as well. But cool. All my changes are pushed. So if I go back to this browser window with my GitHub repo up on GitHub, and when I reload that, you can see that I have my commit here, added function, and in index ipynb. If I click onto that, we hopefully, if it loads, will see my function. There we go. That's the function that I created. So this is just a good thing to do in practice. 1, practice using GitHub. 2, also because GitHub has this thing called contributions, and it just basically shows how active you are on GitHub. It's not a very important thing, to be honest, but some recruiters do look at that. So if you go onto your profile, I don't know if anyone has ever looked into their profile yet, but you have this area over here where you have the number of contributions that you've made in the past year. Because I teach, I don't contribute as much, but you'll basically see that, you know, as you do like more commits and pushes, you'll get darker greens and your number will be better than mine. So that's why it's important to periodically at least push your labs up to GitHub.
So Dish, that was you basically changing on your local computer, like changing the file on your local computer and then basically uploading it to your GitHub account?
Yep, that's right.
Okay.
Yeah.
What kind of, I don't really understand the add feature, like the staging one for Git. What's the point of the staging?
Yeah, so staging in practice is used because on any one project or product, you can be working on multiple files at once. And so let's say you have like file 1, 2, 3, and very likely different people are working on different files. And so let's say, you know, file number 2 has things that are ready to be pushed up, but 1 and 3 are not. So in that case, you would only add and stage whatever changes are in file 2.
Okay.
And so the staging basically lets you choose which files that you're going to stage your changes. Basically, yeah, it selects which files you're changing in GitHub.
Okay, and then can other people see the changes that you've staged?
So staged in the repo, no, because your staged changes and your committed changes, so your staged and committed changes only exist locally.
Right, okay.
So only after you push, then people see them on GitHub.
Okay, gotcha.
Yeah, I'm actually going to draw a diagram right after this to sort of like illustrate what's going on, because there are a lot of terms there. So really quickly, let me get this whiteboard up. All right, so we had some terminology here. Let's start with our lab exists on Learn Co students, right? So we have our lab that started on Learn Co students, and this is a remote repository. Remote is basically anything that exists on github.com. So we started with our Learn Co students remote. What we did was we forked the repo. We forked the repo to your own personal remote. So your own personal, and this is still remote. So personal remote, you still haven't made any changes to it. But now, let's say you want to work offline, you want to just save this lab for like easy reference or something like that. Next thing you do is you do a Git Clone. And that basically makes a copy of the repository, and make sure you do it in HTTPS. Makes a copy of the repository such that you have a local repository. So on your local, you're making a bunch of changes, you're making a bunch of edits, and how you want to save that, I mean, it's good, it's enough to save it locally, but it's always a good practice to have another copy like up on the internet. That next part is, not enough colors, but that next part is the 3-step Git Add, Git Commit, with the -m and message, and then Git push. This diagram is one of the simpler ones. We're gonna go through another process right after this that's gonna have way more arrows. But any questions regarding this, like, you know, cloning and doing your labs locally?
Why can't you just do this with a GUI? Seems like a lot of steps.
There is actually a GUI. There is a GitHub Desktop. I actually only learned about GitHub Desktop about a couple months ago, but it's been around. I personally have never used it. Apparently it's very user-friendly. But yeah, that's one of the GUIs that you can use to do this. I just think it's a good idea to practice using GitHub. It is a lot of steps, definitely annoying, but GitHub is what most companies end up using to like store all their code and to collaborate on different parts of their code base. So I think it's a good practice. But yeah, you can definitely use some sort of GUI.
Can you just quickly recap how you save it locally? Is it just Control-C in your terminal window?
Saving something locally. So saving something locally is actually not the Control-C part. The saving locally is when you edit something on your lab. Let's say you made some changes. This button is actually what is saving it locally. The save button.
We're only seeing the whiteboard right now, so we
can
see.
That's, oh my gosh. Let me reshare this real quick. Thanks for flagging. I always forget. Let's see, desktop. All right, we can see this now? Yeah, so when you open up your Jupyter Notebook, when you're working on your Jupyter Notebook, so this is what I did, changes, is this button that does the saving. So that's what saves it locally. And then that Control-C part is what quits the notebook server. So whenever you have a Jupyter notebook running, it sort of spins up like a local server. I fully don't really understand what that means either. But yeah, so you have this running, and then you can just quit your notebook like this. You can see as I shut this down, connection to notebook server could not be established, but I had already saved, so it's fine, I can close it out. And then when I do Git status again, you can see there were changes. So technically, you don't have to commit your changes up to GitHub, so you can really just leave it like this. But I always think like might as well, since you made changes here, might as well have your changes on GitHub as well. But yeah, that's a good clarifying question, and thanks for flagging that. You could see what I was doing. All right, before I move on, any other questions about working in labs locally? Awesome. So this next thing that we're going to talk about is setting up this study group repo. So I guess like by show of hands or like nods, how many of you have already cloned this study group repo? Nice. Okay, a mixture. That's fine. So when you do this, I can't fork it because it is my own thing, but make sure that you fork it to your own account. That's very important because you are probably going to make changes and like fill out functions from these study group notes that shouldn't affect my version. So the idea of what the study group repo is, as you can see here, phase 1, we had the notebook that we were working on yesterday. How this is going to work is with every study group that has materials, I'm going to upload materials onto this repo that you are then going to pull down to your own local version of this repo. That's the process that we're going to set up right now. I'm going to talk through setting up that process, and then I'll draw a whole diagram of what's really going on. All right, I actually do have the instructions here. So if anyone's more of like a visual, like reading learner, the instructions are here. But step 1, as I'd mentioned, you want to fork and clone this repository. So when you fork it, the URL that you're going to paste in your git clone command, instead of having my username, it'll have your username in this part. And so make sure that it's your username before you clone it. The next thing you're going to do is you're going to add my version as an upstream. And what an upstream is, I'm going to illustrate later. What you're going to do is we're going to add this upstream. Actually, let me demonstrate it with a different repository.
Sorry, I have a quick question. Where do you find this repository in the first place?
Oh, great question. The repository exists on the homeroom. And so the homeroom is linked at the top of our Slack channel. And in the homeroom, it's under resources and links, study group repo. And that brings us to the study group repo here.
Awesome, thanks.
You're welcome. All right, so I actually want to use a different repo just so I can illustrate. Let me see. I think there is one called, I'm just gonna guess. Okay, this is another repo for another cohort that I'm just gonna use to demonstrate what's going on. All right, and as you can see, same instructions. So what I'm gonna do with this, I'm going to fork this repo to my version, to my own account, and that forking is gonna take a while. I think this cohort has already graduated, so a lot of material here. And what I'm gonna do is I'm gonna git clone my version. So download code, HTTPS, make sure that's it. And I actually wanna make sure that I clone this in a place that I want it to be. If I do git clone here, and if I do pwd, print working directory, you can see that I'm still in this lab. Cardinal sin of GitHub cloning, never clone a repo inside another repo. Just causes a bunch of problems. So to be safe, just make sure that you're not already in a repo. And let's actually put this over here. Yeah, let's do that. Actually, I'm gonna put that in test. All right, so I have this test folder here. I think I have another lecture folder here, but all right, let's say I wanna clone my lectures here. This is basically their study group notes. So git clone, there. And because there's a lot of stuff in here, it's gonna take a little while. And if I list my folders, you can see that this exists there now. So let's cd into it. I see ds03. And list, you can see that they have all their resources there. So this step of setting remote, and I'll again sort of explain what that is more in detail, as I think it was easier to explain it as I illustrate it later. But what I'm gonna do is I'm gonna set a remote. And I wanna set the remote as, for you guys, you're gonna set it as my version. So you can pretty much copy whatever I have there. So for this page, I'm gonna copy this, but for you guys, you're gonna copy this, the Git Remote Add Upstream. So we're gonna do Git Remote Add Upstream. Basically what that means, before I illustrate it, you're gonna be pulling changes not from your own remote, but you're gonna pull changes from my remote. So by default, GitHub is gonna pull changes from your own remote, but your own remote doesn't have any of the changes that you want. You wanna pull the changes from my remote. And I think later when I draw the diagram, it'll make a little more sense. So a way to check, again, is when you do git remote -v, it'll look a bit different from what the previous lab looked like. So now you can see that there are two groups of links. There's origin and there's upstream. So under origin, it is my version, and upstream is this Learn Co students version. And Learn Co students was basically their like instructor account. And so for our case, when you do this, you're gonna see that your origin is gonna be the URL with your username, and the upstream will be the URL with my username. Well, I know that's like a lot of terminology, but no worries. Git is one of the hardest things you'll learn, I think.
If you're gonna copy and paste, make sure you change the study group name from 070620 to the 092820.
Oh, that's a really, really good thing to point out. Thank you so much. I totally didn't realize this. Yes, really, really good catch. Thank you so much for that. Yes, make sure that you change 070620 to 092820. Actually, I'm gonna edit it right now. Hopefully this doesn't cause problems. Thanks for catching that.
The P needs to be an F as well.
Thanks. All right, let me do this real quick. And you should be good to go. Let me do one final check. I think that's it. I think this playlist is also our place. I remember changing that. Thank you so much for pointing that out. Okay, so that's what this is. So once you've added the upstream, yeah, that's right. Once you have added the upstream, everything is set up. So if you make a change on like one of the study group notes, like for example, in like this very first notebook, you made a change and let's say you like ran a bunch of these, or you like were testing things on your own. If you do the git add commit push, everything will save. And because git push automatically will push to your own personal upstream. Sorry, your own personal remote. Yeah, I get confused by it as well. But yeah, all right. So how many of you have already cloned this? Like just like a show of hands? All right, so you might be able to try this out. What I'm gonna do right now is I'm actually gonna add the notebook for tomorrow into this repo. So what I'm gonna do is, I'm actually doing this right now. Let me take this and put this in here. All right, so for me to put these new materials up, I'm gonna do this every time we have a study group that has an accompanying notebook. And actually let me just do that super quick. Desktop, and I think it is study group 0928. Yep. So what I'm doing is, let me do a quick Git status. What I'm doing right now is I'm adding this new notebook. So same process, I'll be doing this part. Git commit, topic. 3, and git push. I know why this happened. Don't worry too much about this, but basically, because I had edited the README online, there was a conflict. So basically, I had edited this version online, and then when I tried to push a change up, it saw a conflict and it didn't let me do that. But quickly resolve that. If any of you have already cloned this, you probably have to do a git pull as well. So if you have already cloned this, because I changed this, and I apologize, you might have to type in, what was it? Git pull here. If you run into issues, please just let me know. This is 100% my fault. Anyways, really quickly, let's do a git status and git push. All right. So now, and this is what we're gonna do every time there's a study group that has new materials. You'll see here that now under phase 1, you'll see topic 3's notebook is there. And so the steps that you will do, and I'll actually illustrate this because I unfortunately can't demonstrate this for you guys because this is my repo. These are the 3 steps that you'd have to do. Every time I put up new materials, first you're gonna have to add commit push just in case you have changes on your end. You're gonna do a git fetch upstream. So basically you're fetching any changes that I've made in the upstream. And remember, upstream you've set as my remote repo. You're gonna merge the materials from the upstream to your own repo. And then updated, you can just change your commit message. And then you're gonna git push. Things are gonna come together when I illustrate this right now. But any questions? Was any of that like kind of confusing? Because it is super confusing.
So when I did the git pull to update it, because I already had it cloned, I get a message that says, please commit your changes or stash them before you merge, aborting.
Okay.
You know?
Yeah. So I'm actually, that part is I don't think covered in the curriculum, but type in git stash, S-T-A-S-H, and then do git pull again, and then you should be fine.
Okay, I think we're good. Thank you.
You're welcome. That's my fault. I should have checked. Anyways, all right. So what did we do earlier? So with all these study group materials, we start with my version. So we have this remote that is Ish's version, right? So that's what we started with. What you guys will do is you will fork the repo so that you have your own version remote. Your version. All right. So now your version exists in the remote. You want to clone it to your local machine. And so let's keep this color and let's clone to get local your version. All right, so you're running code, writing functions. So let's see, functions, edits, yada, yada, yada. To keep those changes in your remote, you're going to do your Git Add, commit, and then push. So that's what happens there, and that's on your side. So what happens next is I'm gonna put a new notebook up every time we have a study group that needs a notebook. So what's really happening here is, let's use this color. I have my local version. So I have this, my local version, that I will push up here. And that doesn't matter what I do, but I'm gonna push my local changes up to the remote. You are going to end up fetching those changes from here to here. And you're gonna do a git fetch, a git merge upstream master, and then through that, you get all these new changes on your local machine. And then from here, You go back up to your remote by doing a git push. And that's all the stuff that we're doing here. Questions?
Okay, I have a question.
Yeah.
Okay, so just big picture, what we're talking about is these are the notes for the study groups. So this is what you're going to walk through every day at 2 o'clock. It's not our labs and it's not our lessons. So even though as I've forked it and I've cloned it and it's on my local, like, why am I going to be making changes to it?
So you might not make changes to it. For example, the thing is, in Jupyter Notebook, every time you run a cell, it actually registers as a change. So that's why you'd be changing it. Some people like to actually take notes and like write comments about what's going on, just like for your own note-taking purposes. And so that's also considered a change that you want to keep on your GitHub as well.
Okay, so it's just a way to take some notes for the study group every day, and then I can put them back up to my personal remote in case I want to look at them later.
That's right.
Okay, thanks.
Yeah, I will admit that not everyone uses the notes like this. I know a couple students that actually just refer to the notes on the GitHub page. So let me just reshare this screen again. So
I actually noticed on the one that after yesterday's study group, and I forked it and cloned it, it didn't have the changes that you had made when you were walking through the study group. And is that because you didn't commit them or something like that?
That is intentional. I typically will not have like my changed versions on that GitHub. Just because I think the way that most people use the study group notes is sometimes they'll just like follow along with the study group. So you'll be like executing the cells as I'm executing the cells as well. And also if I were to upload a changed copy, it actually causes a lot of conflict issues.
Okay.
But yeah. Yeah. So any of the changes that exist on the notebook that you see me do during study group will not appear on your version. But for the most part, most of the notebooks that I have, it's just a matter of like running the cells and you'll be able to see what I go through. But cool. Just to let you guys know, most people actually really just click into the GitHub and like read along the stuff on GitHub. So it's really kind of up to you if you want to go through that process of like setting up the study group notes. There will be some notes that need more like coding than others. So it's a good thing to just have set up. But also, admittedly, this is very, very confusing. So happy to walk through it at like one-on-ones if needed. Any other questions about like the study group repo realm of stuff?
You just so I wanted to just clarify, when you make changes locally and then you push that onto your remote, that does not update our clone automatically, right? Our remote clone. That was just like a picture in time. That's why you're saying we have to take it locally and then push it back up to our remote, right?
Yep, you're right. If I were to make, well, yes, whenever you do the fork, it actually takes like, a snapshot in time of whatever was there and takes a copy of that. So if any of you are actually haven't done this process yet and are gonna fork and clone the repo like after this, you will already have the notebooks for topic 1 and topic 3. And yeah, usually, and I will keep track of this, if I'm like working on a notebook and I make changes, I actually should not be pushing up any updated copies of that because those will cause conflicts.
And every day we have to save it in different directories in our local machine.
Oh, that's actually a really good point. You only need to git clone once. So you just have to git clone it once. And so the stuff will just be updated. So for example, if I have, let's see, this is my study groups folder. Actually, another really helpful thing for only Mac users, unfortunately, I'm not sure how to do this on a Windows, but if you type open space period, it actually opens up, all your files like this, where it's like, I don't know, for me easier to see. But yeah, if I have my study groups repo here, as long as I do the fetch, merge, and push steps, new things, new files will just appear. So you don't have to keep recloning it.
Okay, thank you.
You're welcome. Anything else?
I have a question.
Whatever changes,
Sorry, go ahead.
so whatever changes that you make on your remote version is going to be like synced to our remote version?
Yes. Well, kind of indirectly. So whatever changes I make to my remote will be first synced to your local and then pushed up to your remote.
Okay.
Yeah. I don't have that diagram now, but I'll like screenshot the recording and I'll like post that diagram onto the Slack channel.
Okay.
Or I'll make a neater version because my handwriting is not very neat. All right, Sarah, you had a question.
Yeah, I was working through the like the labs and stuff, and I don't understand what the README file is.
Ooh, okay, that's a really great question. So on GitHub, any repo that has a README file is basically what appears here. So GitHub just makes it easier for people to see what's going on. I'll actually have y'all do this for your projects, that in your project repo, you will actually be writing a README that is a summary of your project. And so for different kinds of repos, READMEs have different purposes. So for this study group repo, the README's purpose is to have like these instructions. I can show a different example. Let's see. An example, all right, this is a project that I did. I use this README to just like summarize what I was doing in the project. And so what GitHub does is it automatically looks for this file name, readme.md, and MD stands for Markdown, which is another language. And it just renders the readme.md here. And so I think for our labs, what the labs are, the labs README is actually a copy of the lab itself, which is pretty nifty, just so like you don't have to click into the notebook. But if
it's
you're
normally like a description then of what the repository is?
Yeah, typically it's a description of what it is. I think other examples, let me just click into someone's random README. Oh, actually this is a project that I was working on. Here I have like a bunch of random Spotify projects that I've been playing around with, and I literally just have like what my Spotify projects are in my README. Yeah, that's an example. That's a good question. READMEs are something that we'll actually learn how to write. I'll do like a shorter session during project week on like how to write a README, because it's kind of in another language. But actually, fun fact, not a fun fact, but a fact is if I open up a Jupyter notebook, let's see, what's an example? Let's take a look at, let's just look at this. So an example is any Jupyter notebook in these cells that are text cells, these are all in Markdown. So I don't know if anyone has like accidentally made a cell into Markdown where like you're like coding something and then you accidentally like do this and then your like functions come up like this. That's because you accidentally turned your cell into a Markdown cell. So you can see here, it says Markdown, code cell. And so Markdown is kind of its own language. Anytime you see like a cell with like text or like bodies of words, it's a Markdown cell. I think, let's do this. Other examples, something like this. This is how our labs are written, all in Markdown. So this is a Markdown language, which pretty easy to pick up. I have a cheat sheet for it, which I will send out to all of you when we get to projects.
So it's just a language really used for text that they use to generate the README?
Yeah, exactly.
Okay.
Yeah, that's what it is. And we will see this in like 7 weeks. Cool. Oh, I did not check the chat. But yeah. Oh, cool. Thanks, Austin. Start is the Windows equivalent to open. That's cool. Any other questions so far? Because there are a couple like little things that I also want to talk about with Git.
Okay. Go ahead, someone is talking.
So our local is going to automatically, once we put yours as the upstream, the local is automatically going to get things that you update on your remote, but we're going to have to push them up to our remote if we want to do that.
So it doesn't do it automatically. It's actually the fetch upstream and the merge upstream master that updates your local version. And then, yeah, the second part of what you're saying is right. To get it to your remote is git push.
So we have to do this fetch upstream every time you put a new file out there.
Yep. That's right. I know if anyone's like more savvy, you can actually create like aliases or like shortcuts. So I have a couple of students that like made like a quick shortcut to just do all these steps. I'm not a fan of that. I just like typing. I guess that's why. But that's something you can also look into if you'd like. All right. The next couple of things I wanted to talk about are branches and Git Init. And those I'm going to talk about more conceptually, because for branches especially, we're going to actually get into it with our project. So I think it'll be better to talk about that then, as we have something to work on with branches. So when you create a GitHub repository, it automatically generates a master branch. Actually, fun fact, they are actually going to be changing this terminology soon. I forget what they're going to change it to. I think they're saying like how like master and like I think the other term is like slave branches is not a good term. So they're actually going to be changing it soon. But for now, it's still master branch. If we go on to one of our, let's click onto one of our labs. Branches is actually where we find our solutions. So I'd mentioned, I think yesterday, that solutions is a branch. And so it's basically a slightly different version of the master branch. But this is actually not the typical way that branches are used. The typical way that branches are used is actually with a work in progress. So let me just fork this so I don't change this. So typically, let's say you're working in a company and you have a team and you're working on coding some stuff out. Very typically, you and each person on the team would have their own branch. So usually I would have like a work in progress branch, and we'll walk through this more on when we do our projects. But typically each person has their work in progress branch. And the reason for doing that is if I'm like working on stuff and I'm like constantly, you know, making changes and pushing my changes up to GitHub, I don't want to accidentally push something to the master branch that like, you know, at first glance I thought like, all right, this is going to work, but I push it up to the master, everything breaks. So the work in progress branch or any other branch is more typically used for like testing and making sure that everything's okay before you commit it to master. So let's say this is my work in progress branch, and I will go more into detail about how you will work with these branches. But let's say I make some edits, and let's just make the edits here. In this lab, you will figure out methods. And let's just take this as my change. So this change is made on my work in progress branch. So usually the workflow is I make a change on my work in progress branch, make sure that that change really works, and then I will do a pull request, what's called a pull request, and I will merge that change onto the master branch once I'm absolutely sure that that change is what I want. And so if we go back to the repo, you'll see that in my README, I made this change. I like figure out methods and say, all right, I want this change to be reflected on my master branch as well. And you can see here that I've had recent pushes less than a minute ago. With GitHub, it's pretty user-friendly, I think, in a way, where usually my advice is just press the green buttons. And so let's say I'm good with my changes on my work in progress branch. We're gonna do a compare and pull request. And what I wanna do is take my branch, let's close this out. I want to take my branch and merge it into the master because I'm happy with the changes that I made on my work in progress branch, and I want those changes to be reflected on the master. And so there's this arrow here, and we just want to make sure that this is my work in progress branch. This is the correct repository. The base is here. We actually do not want to merge it to the Learn co-curriculum version. We want to merge it to my own version. You won't have this problem. But yeah, we're just comparing my branch to the master branch on my forked copy. And very likely, you'll have an automatic OK merge. So no obvious conflicts. GitHub is really good at recognizing what changes were made and whether those changes are can be seamlessly added in. And then once it says that it's able to merge, we can just create that pull request. And sometimes if you want, you can put a comment like edited readme, create that pull request. It's gonna take a while to check. No conflicts with the base branch, and we can merge that pull request. Confirm merge, and successfully merged. So now, and I'll go back and like show you all that later, but the pull request is successfully merged and closed. And then now, because my work in progress branch and the master branch have exactly the same material, we can now delete my branch. Cool. And now if we go back and check, my branch is no longer there. The master branch now has my changes. So typically that's the workflow of using branches, and that's the way that you will be using branches during the project, and have way more documentation on how you will be using it specifically for your project. So don't worry too much about this now, just know of the concept of branches. Any questions on this? All right, the last thing I wanted to talk about is Git Init. So Init, short for initialize, is something that is talked about, I believe, in phase 1 in the, let's see where that is. I believe there's like a whole lesson called Git Init. I guess not, but it's in one of the labs that they'll have you do a Git Init. And what Git Init does, it basically initializes any folder in your computer to become a Git repository. So you can make Git repositories on GitHub, but you can also make Git repositories on your local machine. I personally prefer doing it on GitHub because it's more visual. It's easier to see what's going on. But if you see really quick, I think I can close this out. All right, here. On desktop, and let's just make a random new folder. To make a new folder, the shortcut is mkdir, which stands for make directory. Let's call it testing. So if I ls, you can see on my desktop, I have this testing folder. So if we go into testing and we do ls, nothing's there because it's a new folder that I just created. I can turn this into a Git repository by doing Git Init. So just to check, if I do Git Status on something that I haven't done Git Init on, it'll say fatal, not in the Git repository. That makes sense. Once I do Git Init, you can see it initialize an empty Git repository here. And so if I do Git Status, it'll say that no commits yet on branch master. Yeah, that makes sense. What this means and what Git Init actually is doing is actually pretty interesting in the way Git works. If we're doing ls, we don't see anything yet. However, does anyone know the notion of secret files or hidden files? Anyone heard of those? All right, some very subtle nods. But basically, if I do ls-a, which means all, you can see here that there's a little .git file. So in a lot of repos, actually, and let me see if I can find an example. Pretty sure in one of these, let's do this one. If I do ls-a, anything that starts with a period is a hidden file. And basically what's happening when you do a Git Init, you're creating this .git file. And so that's how Git on your computer recognizes that something is a Git repository. Because when you do a .init, it does that .git file. When you clone a repository down, it also creates that .git file. And that's basically what's happening when you do a Git init. Cool. Any questions about that? I very rarely do Git init. One thing to watch out for, make sure you don't do Git init anywhere. I've had students that do a Git init on their base directory. So basically they turn their entire computer into a Git repository, and you don't want to do that. So just make sure you don't do that. One thing you can do to check, just type in Git status and it'll just tell you it's not a Git repository. I will admit I'm one of those people that accidentally did that because I was just like following instructions. They're like, Git init, and I'm like, all right, realized I was in the wrong place, turned my entire computer into a Git repository. When I wanted to Git push something, it tried to push my entire computer's files up onto GitHub, and that was not good. So it was hard to undo. So just make sure you don't do Git init anywhere. Any questions?
When would you go from the base file to learning environment that we created?
That's a good question. So we created the learn environment just because for our lessons, a lot of them they have like different packages have a bunch of dependencies on each other, and we just wanted to make sure that everything's already pre-installed. I actually don't work off the learn environment because I like using the latest versions of packages, and I just update any code or change any code that has updated their methods or functions or anything like that. So it's really kind of up to you. I would say for now, as we're getting started, just stay in the learn environment because you have all the correct packages that are compatible with our lessons for the entirety of the course. All your packages will be fine, except for that like Excel thing that I don't know why that was a thing. That should have been in the learn environment, but I guess it wasn't. Some of you had this Excel issue. But I'd say like once you're comfortable with like, using different packages, or when you start, looking at packages that are outside of the curriculum, then I would say, yeah, I guess you don't have to use your learn environment. The only downside being that from the start, if you haven't done any sort of Python coding on your computer, you wouldn't have any of the packages pre-installed. So something that I had to do was I had to go in and like conda install every single package that I needed. So it's kind of up to you. I'd say like I stopped using LearnEnv probably around like mod phase 4, just because I started like looking into other packages that weren't in LearnEnv. But yeah. But also, if you are in a learn environment and there's a package that you want to use that isn't in learn environment, if you install it while you're in the learn environment, it adds it to your environment. So there's that. But typically, environments are used that basically when you create when you're creating a new project from scratch, you would actually create an environment for that project. And what that does is it takes a snapshot of all the versions that you're using of every package that you're using. And basically in the future, if, let's say 2 years down the road, you want to take a look at one of your old projects, but in those 2 years, you've updated a bunch of packages that maybe aren't compatible with your code from back then, you'd be able to install your environment and then work with the packages with versions from 2 years back, if that makes sense. So yeah, we use environments to make things a little easier for you all. But typically environments are used to like keep the dependencies between packages stable. Cool, those are all the Git things I wanted to talk about. We will be working with Git quite a little bit, especially through getting these study group notes, and also happy to walk through this maybe at the start of either tomorrow's study group or the next few study groups. If anyone has any issues, I think it'll be easier to see what that process is like as someone is facing issues. So we can do that. And also we'll be working with Git with our projects, so we'll get a bunch of experience. But yeah, any overall questions to end off this topic and the study group?
Git Remote -v. I have a question about this command. What this command is trying to tell us?
It just shows us the URLs that your repository is associated with. My screen's still sharing, right? Yeah. So if I do, let's see, this is not a Git. Let's see what's in here that I can use. CD. Let's do this one. So I do Git Remote -v. Basically, you can see that the URLs that are associated to this local repository are these. And you can actually change these URLs. So let's say I change the name of the repo to like, I don't know, 092820 study groups instead of study groups 092820. If I change that, I can actually edit these URLs just to make sure that whenever I'm doing any fetching or pushing, it will go to these URLs. Does that help answer your question?
Yes, thank you.
Awesome. Anything else? All right, just to let you know, Git is super confusing. There's still some parts of Git that I am like constantly Googling. So yeah, everyone finds it hard. I think this ends up being like most people's least favorite part of the bootcamp. So, all right, if there are no further questions, I will see you all at tomorrow's study group, if not at your 101s. All right, I'll talk to you all soon. Bye.
Thank you.